Hello everyone, welcome to another episode of Genie. In today's video, we are going to discuss about the solid principles designing maintainable software. So solid is an acronym for 5 principles that guide the software design and development. These principles help to create code that is modular, flexible and easy to maintain. So, we will explore what are the different 5 principles of solid principles, and let us start writing examples or program snippets for each of these principles. So the first principle in solid principles is the single responsibility principle, or called as SRP. So let us explore what is XRP. SRP states that a class should have only one reason to change, and each class should have a single responsibility or purpose. Applying this SRP allows code readability, maintainability, and reusability. So as you can see in the slide, there is an example. There is a class called customer. It handles the customer related operations, while there is a class called order processor, which is responsible for order processing. So each of this class has got a single responsibility. This maintains the code readability, maintainability, reusability, and it can be easily tested in future. The next principle which we are going to discuss is the open-close principle. So open-close principle states that a software entities like class, modules or functions should be open for extension, but they should be closed for modification. So it means that existing code should not be modified whether new features are added. Instead, it should be extended. Applying this open-close principle promotes code maintainability and prevents unnecessary regressions. Third principle in the list is Liskov Substitution principle, or LSP. LSP states that objects of a superclass should be replaceable with objects of its subclass without affecting the correctness of the program. Subclasses should be used interchangeably with their base class. Applying this LSP, it improves the code extensibility and it promotes polymorphism. So now let us create an example where the Liskov substitution principle as well as open-close principle are explained in detail. So let us jump into that. Let us write an example for open-close principles. So let us start creating a class rectangle, and this class inherits from an abstract class shape, and the shape contains a abstract method calculate area, which returns a double value. Now there are two properties for rectangle, width and height, and we will override the calculate area method to calculate the area of the rectangle. And scalable are defined, allowing the clients to implement only the necessary interfaces. Now let us create another class circle, which also inherits from shape, and circle has a property called radius, and the calculate area method is overridden here, where the area of the circle is calculated. Example, shape class is open for extension, allowing new shapes to be added by creating new classes that inherit from shapes without modifying the existing code. Also, Liskov substitution principle is applied here, since the square class or rectangle class is a subclass of shape and it can be used to be interchangeably with circle without affecting the correctness of the program. So, Liskov substitution principle can be easily applied over here. I hope you like enjoying watching my videos. If you are new here, please click on the subscribe button and the bell notification icon so that you will receive all of my future videos. Do like, comment and share with all the programming enthusiasts you know. The fourth principle in the list, or I, stands for Interface Segregation Principle, where it states that the client should not be forced to depend on the interfaces that they do not use. Keep interface granular and focused on specific client requirements. Applying ISV provides modularity, reduces dependency, and enhances the code clarity. Now, let us create an example to demonstrate this. Now, let us explore the interface segregation principle. So, let us create two interfaces, iPrintable and iScannable. Both iPrintable has a method called print and iScannable has a method scan. Now let us create another class, multi-function printer, which implements both iPrintable and iScannable. In this example, separate interfaces iPrintable. Now let us discuss the last principle called the Dependency Injection Principle. The D stands for Dependency Injection Principle. It states that high-level modules should not depend on low-level modules. Both should depend on abstraction. Abstraction should not depend on detail, rather details should depend on abstraction. Applying the Dependency Injection Principle, it promotes loose coupling, enhances easier testing, and improves the code maintainability. Now let us focus on an example where the Dependency Injection Principle is applied. So let us open the Visual Studio and start writing code for this. Now let us implement dependency injection principles. So dependency injection principle states that abstraction should not depend on details, rather details should depend on abstraction. So in this example, I am creating an interface called iLogger, which has a method log and which accepts a message argument called inString. Now let us create a file logger class which implements the iLogger interface, and the log method is expanded or implemented here. Also, there is another class database logger which implements the same iLogger interface, and the log method is implemented over here. Now let us create another class called order processor, which has a constructor which takes the iLogger as dependency. So in this example, order processor class depends on the iLogger interface instead of the concrete logger implementations like fire logger or database logger. This allows flexibility in choosing the different logger implementations without modifying the order processor class. We have discussed the 5 principles of solid principle. It provides a guideline for designing maintainable and flexible software. Implementing these principles helps us to achieve extensibility and easier maintenance of our code. By following solid principles, developers can build software that is easier to understand, test, and modify. Thank you.